You are sitting somewhere familiar, a room you recognize, a body you assume is yours. The floor beneath you feels solid. The air feels continuous. Time appears to be moving forward at a steady, unquestioned pace. Nothing about this moment seems unstable. And yet, almost everything you are relying on may be an inference rather than a fact. You do not directly experience atoms, fields, or space-time. You experience sensations, patterns, expectations. Your brain assembles these into a model it calls reality. That model feels seamless because it has worked well enough to keep you alive, not because it is necessarily accurate. For centuries, physics reinforced this intuition. Matter was made of things. Space was a container. Time was a flow. Causes produced effects. The universe existed independently of observation, running like a machine whether anyone was watching or not. But the deeper science has looked, the more that structure has dissolved. At small scales, particles are not located until measured. At large scales, space and time lose clear meaning. Fundamental equations describe probabilities, not outcomes. Entire physical properties appear to depend on whether information is observed, erased, or even merely knowable in principle. What feels solid may be statistical. What feels continuous may be discrete. What feels real may be relational, contextual, or incomplete. This is not philosophy detached from evidence. These ideas emerge from experiments that work, from equations that predict reality with disturbing precision, from theories that underpin the technology around you. The question is not whether these models are correct. They already are, within their domains. The question is what they imply. What if the universe is not a thing that exists in the way you think it does? What if reality is not fundamental but derivative? What if what you experience as existence is a surface effect of something that does not resemble a world at all? This is the problem you are about to explore. The comfort of solid things. You begin with an assumption that feels unavoidable. Objects exist. The table remains when you leave the room. The walls persist overnight. This stability feels like direct evidence of reality. But what you actually rely on is consistency of experience, not direct access to an underlying substance. Physics does not describe solidity as a fundamental feature. It describes forces, fields, and probabilities that only average into firmness at human scales. You are accustomed to trusting this stability because it has never visibly failed you. You place a glass on a surface and expect it to remain there. You lean against a wall and feel resistance. These expectations are so deeply ingrained that questioning them feels unnecessary, almost absurd. Solidity appears self-evident. But this confidence is not the result of direct perception. It is the result of repeated confirmation. You are not observing solidity itself. You are observing outcomes that behave as if solidity were real. When physics examines what the table is made of, solidity disappears almost immediately. The atoms composing it are not tiny blocks packed together. They are structured regions of space governed by electromagnetic interactions. Between their nuclei and electrons is mostly emptiness. The resistance you feel does not come from contact between solid things, but from forces preventing overlap. Your hand never touches the table in the way you imagine it does. It is held away by fields you cannot sense directly. At this scale, nothing resembles the intuitive idea of a solid object. There is no continuous substance filling space. There are particles described by wave functions, fields defined mathematically, and interactions that only become stable when averaged over enormous numbers. Solidity emerges not because matter is solid, but because instability cancels out at your scale of perception. What feels firm is what remains statistically reliable. This distinction matters because it reveals how much of reality you infer rather than observe. Your senses do not report the structure of the world. They report patterns that were evolutionarily useful. A perception that treats tables as solid keeps you alive. A perception that accurately conveys quantum uncertainty does not. The world you experience is filtered, simplified, and stabilized long before you become aware of it. Physics reinforces this discomfort by refusing to locate solidity anywhere fundamental. There is no equation in which hardness appears as a basic property. There are only interaction strengths, probability distributions, and constraints. Even mass, which feels like an anchor of substance, turns out to be an emergent effect of fields interacting in specific ways. The deeper you look, the less you find that resembles an object. What you call an object is a region where interactions are temporarily coherent. Its boundaries are not sharp in a fundamental sense. Atoms drift, particles fluctuate. The identity of the table is maintained not by fixed components, but by stable patterns. Replace a few atoms and nothing changes. Replace all of them slowly, and the table remains the same table. Its existence depends on continuity of structure, not on material permanence. This realization quietly undermines the certainty you place in physical reality. If solidity is not fundamental, then your confidence in the existence of things is based on emergent regularities rather than underlying facts. The world holds together not because it is made of solid pieces, but because its deeper rules permit temporary stability. You are not wrong to trust that stability. You need it to function. But it is important to recognize what kind of truth it represents. It is not a truth about what the universe is made of. It is a truth about how the universe behaves at scales where you can survive, think, and remember. The comfort of solid things comes from reliability, not from fundamentality. And as physics continues to peel back the layers, that distinction becomes increasingly difficult to ignore. Matter without substance. At the level of atoms, solidity disappears. Particles do not behave like miniature objects. They occupy regions of probability. What you call matter is mostly empty space structured by interactions. There is no tiny core of hardness holding things together, only forces preventing collapse. Substance becomes a convenient illusion produced by scale. When you imagine an atom, it is tempting to picture a small solar system, a dense nucleus with electrons orbiting like planets. Even this familiar image already misleads you. Electrons do not travel along clear paths. They exist as probability clouds, mathematical descriptions of where an interaction might occur. The atom is not a thing in space so much as a pattern of likelihoods constrained by rules. Between these regions of probability is not filled matter, but near emptiness. If you were to magnify a single atom to the size of a cathedral, its nucleus would be smaller than a grain of sand at the center. The rest would be open space. And yet, when you press your hand against a wall, it does not pass through. Not because the space is filled, but because the forces governing these probability structures forbid overlap. What stops you is not contact between solid entities. It is electromagnetic repulsion. The negatively charged electrons in your atoms resist being forced into the same states as those in the wall. The sensation of touch is your nervous system interpreting this resistance. No surfaces meet, no boundaries collide. There is only interaction. This is where the notion of substance quietly fails. At no point does physics identify a smallest unit that is solid in itself. Quarks, once thought to be fundamental building blocks, are not objects in the classical sense. They cannot be isolated. Their properties depend on context. Fields, which replace particles in more advanced theories, are not material things at all. They are values assigned to points in space and time, abstractions that predict interactions without resembling matter. As you descend further, matter dissolves into mathematics. The equations work. The predictions are precise. But what they describe is not substance occupying space. It is relationships, constraints, symmetries, rules about how systems can change when they interact. The language of physics does not point to stuff. It points to structure. Your intuition struggles here because it evolved to handle environments where this distinction did not matter. At human scales, these probabilistic structures average out. The emptiness cancels. The fluctuation smooth. Stability emerges. You experience a world of objects because instability is statistically suppressed. But this suppression is contingent. It is not guaranteed by the nature of reality itself. This becomes unsettling when you realize how much of your confidence rests on scale. If solidity only appears when countless interactions align, then the world you trust is not anchored by substance, but by overwhelming numbers. The reliability of matter is a collective effect, not a fundamental one. It exists because deviations are rare enough to ignore, not because they are impossible. Even mass, which feels like the ultimate marker of physical presence, does not rescue substance. In modern physics, mass arises from interactions with fields. Remove those interactions and mass vanishes. What you experience as weight is not an intrinsic property of matter, but a consequence of how matter participates in deeper processes. There is no final layer where you arrive at something solid beneath everything else. Each attempt to locate it reveals another level of abstraction, another set of rules, another mathematical structure that behaves consistently without being made of anything you would recognize as material. This does not mean the world is unreal in the sense of being imaginary. It means it is real in a way that does not match your expectations. Reality persists without substance. It functions without solidity. It holds together through constraint rather than through material filling. When you look at matter closely enough, it does not confirm your intuition. It dissolves it. And what remains is not emptiness, but a framework that allows something like a world to appear at all. The measurement problem. You expect measurement to reveal what is already there. In quantum mechanics, measurement does something else entirely. Properties such as position or momentum are not merely uncovered. They are selected. Before observation, the system exists in a superposition of possibilities. After observation, one outcome remains. The theory does not describe what happens in between. This expectation is deeply intuitive. You assume the world has definite properties whether you look or not. Measurement, in this view, is passive. It reports. It does not interfere. Classical physics reinforced this assumption. A thermometer does not create temperature. A ruler does not create length. They simply register values that exist independently. Quantum mechanics breaks this relationship. When you measure a quantum system, the outcome is not determined solely by prior conditions. The system evolves according to precise mathematical rules until measurement occurs. At that point, those rules no longer describe what you observe. Instead of continuing smoothly, the system yields a single result drawn from a range of probabilities. The transition from many possibilities to one actual outcome is not described by the same equations that govern everything else. This gap is not a technical oversight. It is a structural feature of the theory. Before measurement, the system is represented by a wave function. This wave function does not encode a hidden answer waiting to be revealed. It encodes all possible outcomes at once, each with a specific probability. The system is not undecided in the ordinary sense. It is not lacking information. It is described as occupying incompatible states simultaneously. When you measure position, momentum becomes uncertain. When you measure momentum, position loses definition. These properties are not merely unknown, they are undefined. The act of measurement forces the system into a state where one property becomes concrete at the expense of others. What you learn is not what was there. It is what remains after interaction. This is where intuition begins to fail. You want to ask what the particle was doing before you measured it. Quantum mechanics refuses to answer. The theory does not describe a hidden trajectory or a concealed value. It provides no account of an underlying reality that exists independently of measurement. It only provides probabilities for outcomes once measurement occurs. Attempts to restore a classical picture by imagining unknown variables beneath the surface encounter serious obstacles. Experiments have ruled out large classes of hidden variable theories that preserve locality and realism. The universe does not behave as if particles carry pre-existing instructions for every possible measurement. Something more fundamental is missing from that picture. The word observation is misleading here. Nothing requires awareness. A detector is enough. An interaction that irreversibly records information is enough. Measurement is not about looking. It is about coupling a system to the rest of the world in a way that eliminates alternatives. Once information is dispersed, superposition cannot be recovered. What disturbs you is not that measurement affects the system. That is expected. What disturbs you is that the system does not possess definite properties until this effect occurs. The distinction between what exists and what is known begins to blur. Reality appears to wait for interaction before settling into facts. The theory remains silent about what causes this selection. Some interpretations speak of collapse. Others deny collapse entirely and let all outcomes persist in separate branches. Still others redefine what reality means altogether. What they share is an admission that the familiar idea of an observer-independent world is no longer straightforward. You are left with a strange situation. The most accurate theory you have does not describe a single unfolding reality. It describes a structure of possibilities constrained by rules, punctuated by events where one outcome becomes actual for you. Between preparation and measurement, there is no story in ordinary time. There is only a mathematical object evolving without definite properties. This is not a philosophical embellishment. It is the core of how the theory works. Devices built on these principles function precisely because the mathematics is trusted, even though its meaning remains unsettled. Technology advances while interpretation lags behind. The measurement problem is not about ignorance that will eventually be resolved. It is about the limits of description. It exposes a fault line between how you think reality must behave and how it demonstrably does. And once that line appears, it does not remain confined to the microscopic world. It quietly extends outward, forcing you to reconsider what it means for anything to be real at all. Observation. Without a viewer. This dependence on observation sounds psychological, but it is not. No conscious mind is required. A detector, an interaction, or any irreversible exchange of information is enough. The unsettling implication is that reality's properties are not fixed independently of interactions. They emerge at the moment distinctions are enforced. You might initially resist this idea because the word observation suggests awareness. It implies a subject looking at an object. But in physics, observation is a technical term. It refers to any process that correlates a system with its environment in a way that cannot be undone. A photographic plate, a Geiger counter, or a stray photon scattering into space all count. Awareness never enters the equation. This removes an easy escape. Reality does not become definite because you are watching. It becomes definite because information has been irreversibly distributed. Once that happens, alternatives are no longer available. The system has been forced into a particular outcome, not by intention, but by interaction. This reframes what it means for something to exist. You tend to imagine properties as intrinsic. An object has a position because it is there. It has a speed because it is moving. Quantum mechanics undermines this picture. Position and speed are not intrinsic attributes. They are relational outcomes that arise when a system interacts in a specific way. If no interaction enforces a distinction, the property does not take on a definite value. This does not mean the system is hiding that value. It means the value is not part of reality's description at that moment. The universe does not carry a complete inventory of facts waiting to be revealed. Facts are produced. Decoherence theory formalizes this process. When a quantum system interacts with its environment, its possible states become entangled with countless degrees of freedom. The interference between those possibilities effectively vanishes. From your perspective, only one outcome remains accessible. The others are not destroyed, but they can no longer influence what you observe. What matters here is that decoherence does not require consciousness. It happens continuously. Air molecules collide, light scatters, thermal noise spreads. The environment is constantly performing measurements without knowing it is doing so. The world becomes classical not because it is fundamentally classical, but because quantum alternatives are constantly suppressed. This explains why you never see superpositions at your scale, not because they do not exist, but because they are destroyed too quickly to register. The appearance of a definite world is maintained by relentless interaction. Stability is enforced moment by moment. This leads to an unsettling inversion. Instead of properties determining interactions, interactions determine properties. Instead of reality being a stage on which events occur, reality is assembled through events. There is no fixed background carrying objects with predefined attributes. There is a network of interactions from which those attributes emerge. Once you accept this, the idea of an observer-independent universe becomes harder to maintain. Not because observation creates reality, but because reality without interaction lacks definition. A universe with no distinctions is not a universe with hidden facts. It is a universe without facts at all. You are part of this process. Your body, your brain, your instruments are not outside the system. They are nodes within it. When you measure, you are not stepping in from the outside. You are participating in the same mechanisms that give rise to all apparent structure. This does not elevate your role. It diminishes it. The universe does not wait for you. It does not privilege your awareness. It treats your measurements the same way it treats any other irreversible interaction. Your experience of a definite world is a consequence of being embedded in this web, not of overseeing it. The absence of a viewer does not make reality subjective. It makes it conditional. What exists is what can be distinguished. What cannot be distinguished does not yet belong to the world of facts. The line between potential and actual is drawn not by minds, but by interactions that cannot be undone. This is not a comforting conclusion. It suggests that reality is not a finished structure, but an ongoing process of differentiation. And it suggests that beneath the stable world you experience, There is no fixed set of properties waiting patiently in the dark. There is only possibility, continuously shaped into form by contact. Delayed choice and retroactive reality. Some experiments allow measurement choices to be made after a particle should have already decided how it behaved. The results remain consistent regardless of timing. It is as if the particle never committed to a history until the final measurement forced one. Cause and effect stop behaving like a one-way sequence. You are accustomed to thinking that events settle as they occur. A particle passes through an apparatus, makes a choice, leaves a trace, and then moves on. Later measurements merely confirm what has already happened. This sequence feels unavoidable. Past first, future second. Decision, then record. Delayed choice experiments violate this order. In these setups, a particle is sent toward an arrangement that would normally require it to behave either like a wave or like a particle, but the critical detail is postponed. The experimental configuration that determines which behavior is revealed is chosen only after the particle has already entered or even passed the region where that behavior should have been decided. If reality worked the way you expect, this would cause a contradiction. The particle should already have behaved one way or the other. Changing the measurement later should be irrelevant, but the results do not reflect that intuition. The particle behaves consistently with the final measurement choice, regardless of when that choice is made. This does not mean the particle changes its past. It means that the concept of a fixed past behavior may not apply. Before measurement, the theory does not assign the particle a definite history. It assigns it a superposition of possible histories. Wave-like and particle-like descriptions coexist as potential narratives, not as events that have already occurred. The experiment does not reveal which story was true. It determines which story becomes applicable. This forces you to confront an uncomfortable idea. The past, at least at the quantum level, is not a settled sequence of facts independent of present conditions. It is constrained by what is eventually measured. The distinction between what happened and what could have happened remains unresolved until interaction enforces it. You might try to preserve causality by imagining that the particle always knew what measurement would be chosen later. But this implies a form of foresight that stretches the concept of physical law beyond recognition. The mathematics does not support such a narrative. It does not require information to travel backward in time. It simply does not assign definite properties until measurement occurs. What collapses here is not physics, but chronology as you understand it. Cause and effect remain intact at the level of observable outcomes. No signals travel faster than light. No information is sent into the past. Yet the structure of explanation changes. Events are no longer ordered solely by temporal sequence. They are ordered by correlations established through measurement. The future measurement does not reach back and alter the past. Instead, the past was never fully specified to begin with. You assumed it was. The experiment exposes that assumption as unnecessary. This has consequences beyond laboratory setups. If histories are not fixed until distinguished, then the universe does not carry a complete record of itself at every moment. What exists is a range of allowable descriptions, constrained by laws, but not resolved into a single narrative until interaction demands one. You rely on the idea of a definite past to ground memory, responsibility, and explanation. At human scales, this reliance is justified. Decoherence locks histories into place so effectively that alternatives become inaccessible. But the quantum level reveals that this definiteness is not fundamental. It is imposed. The delayed choice experiments show you the boundary of that imposition. They reveal that what you call history is in part a reconstruction conditioned on present facts. The story of what happened is written in a way that remains consistent, but not necessarily pre-existing. This does not make reality arbitrary. The outcomes obey precise statistical rules. What it makes fragile is the idea that the universe unfolds like a recorded film, frame by frame, with each moment permanently fixed as it passes. Instead, the universe behaves more like a system that constrains consistency across time without committing to unnecessary details. Facts are established only when they must be. Until then, possibility is sufficient. When cause and effect stop behaving like a one-way sequence, you are not witnessing a breakdown of logic. You are witnessing the limits of a model that assumed more structure than reality requires. The unsettling implication is not that the future changes the past, but that the past is thinner than you believed. And once that is accepted, the direction of time itself begins to feel less secure. Entanglement and the loss of locality. Entangled particles share a single quantum state even when separated by vast distances. Measure one, and the other responds instantly. No signal travels between them, yet the correlation is real. The universe does not always respect the idea that distant things are independent. Space loses its authority as a separator. You are trained to believe that distance matters. If two objects are far apart, what happens to one should not immediately affect the other. This intuition is woven into everyday experience and classical physics alike. Locality feels like a basic rule of existence. Causes operate nearby, influences weaken with separation, and space acts as a buffer between events. Entanglement violates this expectation at its foundation. When two particles become entangled, they are no longer fully describable as separate entities. Their properties are defined only jointly. Even when moved far apart, the system must be treated as a single whole. Measure one particle's property, and the corresponding property of the other is fixed at the same moment, regardless of distance. This does not mean information travels between them. No usable signal is sent. No message is exchanged. Relativity remains intact. And yet, the correlations exceed what any local explanation can provide. The outcomes are coordinated in a way that cannot be accounted for by shared history alone. This coordination has been tested repeatedly. Experiments rule out explanations based on hidden instructions carried by the particles. The universe does not behave as if each particle knew in advance how to respond to every possible measurement. Instead, the results suggest that the measurement outcomes are not independent events at all. They are parts of a single, distributed fact. What collapses here is the idea that objects have their own private states. In entanglement, the state belongs to the system, not to its parts. The particles are not connected by something traveling through space. They are connected by not being fully separate in the first place. This forces you to reconsider what separation means. If two objects can be spatially distant yet not independent, then space is not the fundamental divider you assumed. It organizes appearances, but it does not necessarily organize reality at its deepest level. The discomfort comes from how cleanly this conclusion follows from the mathematics. Entanglement is not an exotic add-on. It is a generic feature of quantum systems. As soon as particles interact, entanglement tends to form. Isolation is the exception, not the rule. The world naturally knits itself together in ways that defy spatial intuition. At human scales, you do not notice this because entanglement is fragile. Interactions with the environment quickly spread it out and destroy observable correlations. Decoherence restores the appearance of separateness. Objects regain individuality, locality reasserts itself. But this restoration is effective, not fundamental. Beneath it, the universe remains non-local in structure. This does not imply that everything influences everything else directly. It implies something more subtle and more unsettling. The basic units of reality may not be things in space at all. They may be relationships that only appear localized under certain conditions. When you insist on describing reality as composed of independent objects moving through space, entanglement appears paradoxical. When you instead describe reality as a web of correlations, space begins to look like an emergent ordering principle rather than a foundational one. This shift has consequences for how you think about causation. In an entangled system, the explanation for a result is not found entirely in the past of one particle. It is found in the structure of the whole system and in the measurement context. Causes stop being localized events and become global constraints. You are not witnessing faster-than-light influence. You are witnessing the failure of the assumption that influence must be local. The universe does not need to send signals across space if the division imposed by space is not fundamental to begin with. This realization quietly undermines the picture of a universe made of separate pieces interacting across distances. It suggests instead a universe that is fundamentally unified, where separations are practical distinctions rather than ontological ones. Space still matters. It shapes what you can access and control. It limits communication and action. But it no longer guarantees independence. At the deepest level you can probe, the universe behaves as if parts of it remain connected regardless of how far apart they appear. And once space loses its authority as a separator, the idea of a world composed of distinct, self-contained things becomes increasingly difficult to defend. Information as the fundamental currency modern physics increasingly treats information as more basic than matter or energy. Physical laws can be rewritten in informational terms. Black hole physics suggests that what matters is not what falls in, but what information is preserved. Reality begins to look like a bookkeeping system rather than a collection of objects. You are used to thinking of information as something secondary. Data describes the world. It does not constitute it. But in fundamental physics, this hierarchy has begun to invert. Equations that once tracked particles and forces can be reformulated to track correlations, entropy, and informational constraints. What remains invariant is not substance, but structure. Information, in this context, does not mean meaning or messages. It refers to the number of possible states a system can occupy, and the rules that govern how those possibilities change. To know the information content of a system is to know how distinguishable its configurations are. Physics increasingly cares about this because distinguishability is what survives when familiar notions of matter dissolve. Nowhere is this shift clearer than in the study of black holes. According to classical reasoning, anything that falls into a black hole is lost forever. Matter disappears behind the event horizon. History ends. But quantum mechanics forbids the destruction of information. If information were truly erased, the theory would break. This conflict forces a choice. Either quantum mechanics fails in extreme conditions, or black holes do not destroy information. Decades of work point toward the latter. The mass, charge, and spin of a black hole are not enough to describe what it contains. Somehow, the information about everything that falls in must be preserved. What is unsettling is where that information appears to reside. Calculations suggest it is not stored in the volume of the black hole, but on its boundary. The event horizon behaves like a surface that encodes information about the interior. The amount of information scales with area, not volume. This is not how objects work. It is how data storage works. This observation generalizes. In several theories, the maximum information content of any region of space depends on its surface area. Space itself seems constrained by informational limits. You cannot pack arbitrary detail into a volume. Reality enforces a bookkeeping rule on how much can be distinguished. Once you take this seriously, matter begins to look like a way information organizes itself. Particles become excitations of fields. Fields become ways of encoding relationships. Energy becomes a measure of how those relationships change. At no point do you encounter something that must exist as substance rather than as pattern. Even the laws of physics begin to resemble consistency conditions on information processing. They specify which transformations are allowed and which are forbidden. They do not describe what reality is made of, only how it can evolve without contradiction. This perspective reframes existence itself. A thing exists to the extent that it carries information and participates in lawful transformations. An object that cannot be distinguished from its environment carries no information and, in a meaningful sense, does not exist as a separate entity. Your identity, under this view, is not anchored in material continuity. It is anchored in informational continuity. The persistence of memory, structure, and correlation defines you more than the atoms that pass through your body. Those atoms are replaced constantly. The pattern remains. This does not reduce you to a simulation or a code in a simplistic sense. It removes the need for a deeper substrate altogether. If information is fundamental, there is nothing beneath it that needs to be made of something else. The question, what is it made of, loses its grip. The universe begins to resemble a system that conserves distinctions. It tracks what can be known in principle, not what occupies space. Events matter because they change informational relationships. Histories matter because they constrain possible futures. When you look at reality through this lens, objects become secondary. Space becomes a way of organizing access. Time becomes a way of ordering transformations. What persists is not matter, but constraint. This does not make reality abstract in a dismissive sense. It makes it precise in an unfamiliar way. The world still behaves consistently. It still resists you. But the source of that resistance is not substance pushing back. It is a structure of rules that limits how information can be arranged. If reality is a bookkeeping system, it is not one that someone designed. It is one that enforces coherence. And once coherence replaces substance as the foundation, the intuition that the universe must be made of things begins to feel less necessary and less secure. The black hole. Paradox. Black holes appear to erase information, which should be impossible according to quantum mechanics. Resolving this conflict has forced physicists to reconsider what space, time, and locality mean. Some solutions imply that information is encoded on surfaces, not volumes. The interior becomes less real than the boundary. You might think of a black hole as an object that swallows things. Matter falls in, crosses a horizon, and disappears. From the outside, only mass, charge, and spin remain. Everything else seems lost. For a long time, this picture was accepted as an unfortunate but tolerable consequence of gravity. Quantum mechanics does not tolerate it. According to quantum theory, information cannot be destroyed. If a system evolves according to the laws of physics, then, in principle, its prior state can always be reconstructed from its future state. Destroy information, and the theory loses its predictive power. Probabilities stop adding up. the logic collapses. Black holes appear to violate this rule. If information falls in and never returns, then the universe forgets. That forgetting would ripple outward, undermining the consistency of quantum mechanics everywhere. This is not a localized problem. It is a foundational one. To resolve this, physicists were forced to abandon comfortable assumptions. One possibility was that information really is destroyed and quantum mechanics must be modified. Another was that information escapes in some subtle way, hidden in radiation that appears random but is not. The latter path has proven more consistent. Black holes emit radiation. Over unimaginably long times, they evaporate. If this radiation carries information, then the information is not lost. But this creates a new problem. The radiation seems thermal. It does not obviously encode the details of what fell in. To preserve information, space and time must behave in ways that defy classical intuition. Calculations suggest that information is not stored deep inside the black hole. Instead, it is encoded at the event horizon. The horizon acts like a two-dimensional surface that contains everything needed to describe the interior. The amount of information scales with area, not volume. This is not how physical objects are usually described. It is how databases are. This leads to a radical implication. The interior of the black hole may not exist in the way you imagine. It may be a derived description, reconstructed from information stored elsewhere. The boundary is fundamental. The inside is secondary. If this is true, then space itself is suspect. Volume becomes an emergent concept, not a basic one. The idea that reality fills space with content gives way to the idea that reality is constrained by surfaces that encode relationships. Locality also begins to erode. If information about the interior is accessible from the boundary, then what happens inside is not entirely isolated. The clean separation between regions of space breaks down. The black hole no longer hides information behind a wall. It redistributes it in an unfamiliar way. You might hope this is a special case, confined to extreme objects, but the logic does not stay contained. The same principles appear in broader theories of quantum gravity. They suggest that the universe as a whole may obey similar rules. Regions of space may be fully describable by information at their edges. The paradox forces a choice. Either the laws you trust break down at black holes, or your understanding of space, time, and existence must change. The latter option is increasingly difficult to avoid. This reframing has a quiet but profound effect on how you think about reality. If the interior of a black hole is less real than its boundary, then depth and containment are no longer reliable guides to fundamentality. What looks like an inside may be a convenient fiction. Reality becomes something that is defined by what can be encoded and preserved, not by what seems enclosed. The universe stops behaving like a container filled with things. It starts behaving like a system that tracks information across boundaries. The black hole paradox does not offer a comforting resolution. It offers a trade. In order to preserve consistency, you give up the idea that space is fundamental. You give up the idea that locality always holds. You give up the idea that reality must be built from volumes of substance. What remains is a universe that conserves information at all costs, even if that means rewriting the rules you thought were unbreakable. And once that rewrite begins, the intuition that the universe is made of things existing in space becomes increasingly difficult to sustain. Reality on the edge. The holographic principle proposes that everything within a region of space can be described by information stored on its boundary. If true, the three-dimensional world you inhabit is a projection of a lower dimensional description. Depth becomes derivative. Volume becomes an interpretation. You are used to thinking that interiors matter more than surfaces. What is inside a room feels more real than the walls that enclose it. What fills a volume seems more substantial than the boundary that contains it. This intuition is deeply embedded in how you navigate the world. Space appears to be something that is filled. The holographic principle reverses this logic. According to this idea, the complete physical description of a region does not require access to its interior. Everything that can happen inside can, in principle, be encoded on the surface surrounding it. The boundary carries the information. The interior is a reconstruction. This is not a metaphor. It emerges from attempts to reconcile quantum mechanics with gravity. Calculations show that the maximum amount of information a region can contain scales with the area of its boundary, not with its volume. Add more space inside, and you do not gain proportional informational capacity. The universe imposes a limit that behaves like a surface law. If you take this seriously, then the three-dimensional world you experience is not fundamental. It is an effective description, generated from something that lives on a lower dimensional edge. What you perceive as depth is not basic. It is inferred. This does not mean the world is fake. It means its dimensionality may be contingent. The solidity of space, like the solidity of matter, becomes an emergent feature rather than a given. The structure that actually carries reality is more abstract, more compressed, and less intuitive. You might try to imagine this as a projection, like a hologram on a credit card. But even that analogy falls short. In a hologram, the projected image depends on light and perspective. In the holographic principle, the projection is not optional. It is the only way the interior exists at all. The implication is subtle but destabilizing. If the interior of space is reconstructed from boundary data, then space is not a container. It is a derived coordinate system that organizes information in a way that feels continuous and local to you. Locality becomes a feature of the reconstruction, not of the underlying description. This helps explain why gravity behaves so differently from other forces. Gravity appears to care about geometry, curvature, and horizons. It responds to how information is distributed, not just to what objects are doing. In a holographic framework, gravity is not a force propagating through space. It is an emergent effect of how information on the boundary is arranged. From this perspective, moving through space is not fundamental motion. It is a change in how information is accessed within the reconstruction. Distance becomes a measure of relational complexity, not of separation in a pre-existing arena. You still experience space as continuous because the reconstruction is stable. The rules that generate it are consistent. At your scale, the illusion does not break. But illusion is the wrong word. This is not deception, it is emergence. The same way temperature emerges from molecular motion, space may emerge from informational structure. The unsettling part is not that the world might be a projection. It is that there may be no deeper three-dimensional reality beneath it. The projection is the reality you get. There is no hidden interior waiting behind the scenes. If that is the case, then asking what space is made of becomes the wrong question. Space is not made of anything. It is an organizational effect. What is fundamental are the constraints that determine how information can be encoded, preserved, and transformed. Reality on the edge means that what appears central is not. The boundaries matter more than the volumes. the limits matter more than the contents. And what you experience as a rich, extended world may be the surface expression of something far more minimal. Once depth becomes derivative, the intuition that the universe must be built from inside out begins to fail. Reality may instead be built from the edges inward, with the interior arriving last, as a consequence rather than a foundation. Space as an emergent phenomenon. In several leading theories, space is not fundamental. It emerges from patterns of entanglement or mathematical relationships. When those relationships change, space itself dissolves. Distance is no longer a basic feature of the universe, but a secondary effect of deeper structures. You are accustomed to treating space as the stage on which everything else happens. Objects occupy it. Events occur within it. Even when matter disappears, space seems to remain, empty but present. This intuition feels unavoidable because every experience you have is spatially organized. You cannot imagine perception without extension. Physics increasingly suggests that this intuition is misplaced. In some approaches to quantum gravity, space does not exist at the most basic level. There are no points, no distances, no background geometry. Instead, there are abstract relationships, often encoded mathematically, that do not resemble a place. Only when these relationships take on particular patterns does something like space appear. One way this emergence occurs is through entanglement. When many quantum systems are entangled in specific ways, their correlations can be arranged so that they behave as if they were neighbors in space. Change the pattern of entanglement, and the notion of proximity changes. What you call distance reflects how strongly systems are correlated, not how far apart they are in a pre-existing arena. In this picture, space is not where things are, it is how things are related. This has a profound consequence. If spatial separation is a measure of relational structure, then altering that structure can effectively alter space itself. Regions can become closer or farther apart without anything moving. Entire dimensions can appear or disappear depending on how the underlying relationships are organized. The mathematics that describes these models is precise, not speculative. It reproduces familiar features of spacetime when conditions are right, but it also predicts situations where spacetime breaks down entirely. At extreme scales or energies, the geometry you rely on ceases to exist. The concept of location loses meaning. This breakdown is not a failure of the theory, it is a prediction. It suggests that asking where something is becomes meaningless when the conditions that generate space are absent, just as temperature loses meaning when there are too few particles. Space loses meaning when there are too few relationships. You might try to preserve intuition by imagining a deeper space beneath the emergent one. But the theories resist this move. They do not point to a hidden background. They point to absence. Space is not waiting to be revealed. It is assembled. This reframes how you think about distance. Two systems can be spatially distant yet deeply connected at the fundamental level. Others can be close in space, yet only weakly related. Spatial arrangement becomes a convenient summary of deeper facts, not a primary organizing principle. This also alters the role of gravity. If space emerges from relationships, then gravity is not something that acts within space. It is something that shapes how space comes into being. Curvature becomes a description of how relational patterns change, not of how a pre-existing fabric bends. At your scale, none of this is visible. The patterns that generate space are stable and uniform enough that space appears continuous and fixed. You can measure distances reliably, you can navigate, you can build. Emergence does not imply fragility, it implies dependence. But dependence matters. It means that space is contingent on deeper conditions being met. If those conditions fail, space does not merely distort, it disappears from the description altogether. This possibility forces a re-evaluation of what it means for something to exist. If existence depends on location, and location depends on emergent space, then existence itself becomes conditional. Things exist not because they occupy space, but because they participate in the structures that give rise to space. The idea of an empty universe becomes suspect. Without relationships, there is no emptiness to speak of. There is no container left behind. There is simply no spatial description at all. When space is no longer fundamental, the universe stops resembling a place. It begins to resemble a system of constraints from which place-like behavior arises under the right conditions. And once that shift occurs, the confidence that reality must be laid out somewhere becomes increasingly difficult to justify. Time without flow. You experience time as a continuous progression. Physics does not. Fundamental equations often treat time as reversible or static. Some models suggest time emerges from correlations between states, not from a universal clock. The sense of flow may be a property of memory, not of reality. You feel time moving because you remember a past and anticipate a future. Moments appear to arrive, linger briefly, and then disappear. This flow feels so immediate that questioning it seems almost incoherent. Even when you doubt everything else, the passage of time feels undeniable. Physics does not share this confidence. At the most fundamental level, many of the equations that describe the universe do not distinguish between past and future. They work just as well if time runs forward as if it runs backward. Nothing in their structure marks a preferred direction. The laws do not care which way time points. This creates a problem. If the laws are time symmetric, where does your experience of irreversible flow come from? One response is to appeal to entropy. Systems tend to move from ordered states to disordered ones. This statistical tendency defines an arrow of time. You remember the past because it was more ordered. You cannot remember the future because it is less constrained. But this explanation does not place time itself into the equations. It places asymmetry into boundary conditions. The laws still do not flow. Only certain solutions do. Some theories go further. They suggest that time, like space, is not fundamental. It does not exist as a universal parameter ticking away in the background. Instead, time emerges from correlations between physical states. One system changes relative to another, and this ordering is interpreted as temporal sequence. In this view, there is no global now. There is no objective present sweeping across the universe. There are only relationships between configurations. What you call time is a way of indexing change using internal reference frames. This aligns uncomfortably well with how time appears in relativity. Different observers disagree about simultaneity. Events that are present for one observer can be past or future for another. There is no universal slice of reality that everyone shares. The flow you feel is not mirrored by the structure of space-time. Some interpretations take this seriously and propose a block universe. All moments exist equally. Past, present, and future are laid out together in a four-dimensional structure. Nothing moves through this block. Your consciousness does not ride a wave of time. It traces a path through a static landscape. In such a universe, becoming is not a fundamental process. It is a perspective effect. You experience change because your brain encodes information asymmetrically. It stores records of certain states and not others. The sense of passage arises from how memory works, not from how reality unfolds. This idea is difficult to accept because it conflicts with every subjective cue you have. You feel time passing even when nothing else changes, but feeling is not evidence of fundamentality. Hunger does not prove the existence of an intrinsic lack. Pain does not prove damage must exist. Experience reports conditions. It does not define ontology. If time emerges from correlations, then it can also dissolve when those correlations fail. In extreme physical regimes, such as near singularities or at the smallest scales, the usual ordering of states may break down. The concept of before and after may lose coherence. There may be no meaningful temporal description at all. This does not mean events stop happening. It means that the framework you use to describe happening ceases to apply. Just as space can dissolve when relational structure collapses, time can dissolve when change cannot be consistently ordered. The unsettling implication is that the flow you trust most may be the least fundamental feature of reality. It may be a narrative constructed by systems that record, compare, and update information. Remove memory, remove asymmetry, and the sensation of passage disappears. You remain embedded in this process. Your identity depends on temporal continuity. Your thoughts require sequencing. You cannot step outside time as you experience it. But physics does not require that experience to be universal or basic. Time, like solidity and space, may be something that happens rather than something that exists. A way complex systems track change when conditions allow it. And if that is true, then the question is no longer where time goes, but why it appears at all. Once time loses its flow at the fundamental level, the universe begins to resemble not a story being told, but a structure being sampled. And your experience of moving through it becomes something that needs explanation, not something that can explain everything else. The block universe. In relativistic physics, past, present, and future all coexist within a four-dimensional structure. There is no objectively moving now. Your experience of becoming is not mirrored in the structure of space-time. Change becomes a feature of perspective, not of the universe itself. You instinctively believe that the present is special. It feels different from the past, which is gone, and the future, which has not yet arrived. The present seems to advance, moment by moment, carrying you with it. This sense of progression feels so fundamental that it is easy to assume the universe itself shares it. Relativity denies this assumption. In the relativistic description of space-time, events are laid out in a four-dimensional structure that includes time as a dimension similar to space. An event does not come into being and then vanish. It occupies a fixed position in space-time. What you call the past still exists as a region of this structure. What you call the future exists as another. There is no global present slicing through this structure. Different observers, moving relative to one another, disagree on which events are simultaneous. An event that is present for you may already be in the past for someone else, or still in the future. There is no observer-independent answer to the question of what is happening now. This is not a limitation of measurement. It is a consequence of how space-time is structured. If there is no universal present, then there is no objective flow of time sweeping across the universe. Nothing in the equations marks a moving boundary between what exists and what does not. All events are equally real within the space-time manifold. This leads to the idea known as the block universe. In this view, the universe is not something that unfolds. It simply is. The entire history of reality, from what you call the beginning to what you call the end, exists as a single static structure. Change does not happen to the block. Change is how you encounter different parts of it. This is deeply unsettling because it reframes your most basic intuitions. You do not experience yourself as a static structure. You experience yourself as becoming. Thoughts arise, decisions are made, the future feels open, the past feels fixed. The block universe does not deny these experiences. It reclassifies them. Becoming is not a property of space-time. It is a property of consciousness embedded within space-time. Your brain traces a path through the block, accessing different states along that path. The sense of flow comes from how those states are ordered and remembered, not from the block changing. From this perspective, nothing objectively happens. There is no moment when the future turns into the present. There is no cosmic clock advancing. There are only different regions of space-time and systems within them that are structured to experience sequences. This raises an uncomfortable question. If the future already exists, in what sense is it open? If your decisions are located at fixed points in space-time, are they genuinely free, or merely observed as free from within the block? Relativity itself does not answer this. It describes structure, not agency. But it does remove the idea that freedom relies on an objectively unfolding present. The universe does not wait to see what you will do. What you will do is already part of its structure, even if you have not yet experienced it. This does not make your experiences illusory. It makes them local. From within the block, you cannot access all of space-time at once. You experience one slice at a time, ordered by memory and causation. That ordering is real for you, even if it is not written into the universe as a whole. The block universe replaces a dynamic cosmos with a static one, but it does not eliminate motion or change as phenomena. It relocates them. Motion becomes a relationship between events. Change becomes a comparison between states. Flow becomes something that happens inside certain systems, not something that governs everything. Once this view is taken seriously, time stops being the background against which reality unfolds. It becomes part of the structure that reality already is, and the feeling that the present is uniquely real becomes a feature of how you are situated within that structure, not a clue to how the universe is built. The unsettling implication is not that time is unreal, but that its most familiar feature, its passage, may belong to you, not to reality itself. Probability instead of history. Quantum mechanics predicts outcomes statistically, not narratively. It does not describe what happens, only what is likely. Between preparation and measurement, the theory offers no story. The universe may not evolve in the way you imagine. It may only constrain outcomes. You are accustomed to explanations that tell stories. Something happens, then something else follows. Causes precede effects. Events form a chain that can be traced backward and forward. Even when details are missing, you assume there is a hidden narrative connecting them. Quantum mechanics does not provide such narratives. The theory begins with a preparation. A system is placed in a certain state. It ends with a measurement. An outcome is recorded. Between these 2 points, the formalism offers no description of what actually occurs. There is no sequence of intermediate events. There is only a mathematical object that encodes probabilities for possible outcomes. This is not a temporary gap waiting to be filled. It is how the theory is constructed. The wave function evolves smoothly according to precise equations. But that evolution does not correspond to a physical process unfolding in time in the way you imagine. It is a rule for updating probabilities, not a depiction of motion or change. When you ask what the particle was doing between measurements, the theory does not answer because it does not need to. All that matters is the statistical relationship between preparation and outcome. The intervening story is unnecessary. This is deeply counterintuitive because your experience is built on narratives. You understand yourself as a sequence of events. You remember actions, decisions, and consequences. You expect the universe to work the same way, but at the quantum level, explanation shifts from history to constraint. The universe does not tell a story about how an outcome comes to be. It enforces a distribution of outcomes that are allowed to occur. What happens is what fits within those constraints. The path taken to get there is not specified. This becomes especially clear in phenomena like quantum interference. The probability of an outcome depends on all possible paths, even those that seem mutually exclusive. These paths are not alternative histories that the particle actually followed. They are contributions to a probability calculation. The theory sums over possibilities, not over events that took place. When measurement occurs, one outcome is realized. The others vanish from your description. Not because they failed to happen in time, but because they were never histories to begin with. They were options weighted by likelihood. This reframing alters your sense of causation. Causes do not push effects forward through time. They constrain what effects are possible. Preparation limits the range of outcomes. Measurement selects one. The connection between them is statistical, not mechanical. At human scales, this distinction is invisible. The constraints are so tight and the probabilities so sharply peaked that outcomes appear deterministic. Narratives reemerge. Causes seem to produce effects reliably. But this reliability is an approximation, not a foundation. When you rely on probability instead of history, the past becomes less definite. The present outcome does not require a single, well-defined sequence of prior events. It requires consistency with the constraints imposed by the theory. The universe does not need to keep track of what happened step by step. It only needs to ensure that outcomes fit together without contradiction. This idea echoes earlier themes. The past is not a fixed record stored somewhere. It is a reconstruction conditioned on present facts. What you call history is the story you tell to make sense of outcomes that obey statistical rules. This does not mean anything can happen. The probabilities are precise. They are tested and confirmed. The universe is not arbitrary. It is tightly constrained. But those constraints do not take the form of a narrative unfolding in time. The unsettling implication is that the universe may not be evolving in the way you imagine at all. It may not be moving from state to state in a continuous story. It may instead be a system that defines which outcomes are allowed and with what likelihood, leaving the notion of what happens in between undefined. Once explanation shifts from history to probability, the intuition that reality must be a sequence of events loses its force. The universe stops behaving like a story being told and starts behaving like a set of rules being satisfied. And if that is true, then the sense of temporal continuity you rely on may be something you impose on the world, not something the world provides. Multiple worlds without collapse. One interpretation removes collapse entirely. All possible outcomes occur, each in a separate branch. You experience one because you are part of it. Reality becomes a branching structure without a single authoritative history. Existence multiplies without resolution. You are used to thinking that uncertainty ends when a measurement is made. Before, there are possibilities. After, there is a fact. One outcome becomes real, and the others disappear. This expectation is so natural that it feels almost definitional. Reality, you assume, must eventually choose. The many worlds interpretation denies that this choice ever happens. In this view, the wave function never collapses. It always evolves smoothly, according to the same equations, without exception. When a measurement occurs, the system does not jump from possibility to fact. Instead, the universe divides. Every possible outcome is realized, each in a different branch of reality. Nothing special happens at the moment you observe a result. There is no selection, no pruning of alternatives. There is only separation. The universe contains all outcomes, but they no longer interact. You experience one outcome because you are part of one branch. Versions of you exist in the others, equally real, each recording a different result. There is no privileged history. There is no single story the universe tells. There is only a vast structure of diverging trajectories. This idea feels extravagant because it violates a deep preference for economy. Why accept countless unseen worlds when one would seem sufficient? But the interpretation is not proposed for dramatic effect. It is proposed to remove an inconsistency. The equations of quantum mechanics never describe collapse. Collapse is added by hand to explain why you observe definite outcomes. Many worlds removes this addition. It takes the mathematics seriously and accepts the consequences. If the equations say all possibilities persist, then all possibilities persist. From this perspective, probability takes on a new meaning. Probabilities no longer describe which outcome will occur. All outcomes occur. Probabilities describe how measure is distributed across branches. They tell you how likely you are to find yourself in one branch rather than another. This reframing shifts the role of chance. Chance does not govern reality. It governs self-location within reality. You are uncertain not about what the universe will do, but about which version of you will experience. History, under this view, is not unique. The past branches just as the future does. There is no single chain of events leading from origin to present. There are countless overlapping histories, identical up to a point, then diverging whenever quantum alternatives arise. This challenges the idea that the universe must have a definite narrative. Instead of one authoritative history, there is a tree of histories, none more real than the others. The sense that things happened one way rather than another is local, not global. You might object that this multiplies reality beyond necessity, but from within the theory, nothing is being added. The wave function already contains all possibilities. Many worlds refuses to discard any of them. What feels like excess is simply the refusal to erase. What makes this interpretation unsettling is not just the number of worlds, it is the loss of finality. No outcome truly resolves uncertainty. Every decision, every measurement, every random event leads to further branching. Existence does not converge, it proliferates. You cannot observe the other branches. Decoherence ensures that they remain inaccessible. They do not interfere with your experience. From within your branch, the world behaves as if collapse occurred, but this appearance is not fundamental. It is a consequence of separation. This creates a strange inversion. The familiar world of definite outcomes is not the deepest level of reality. It is a local perspective within a much larger structure. Definiteness is not imposed by the universe. It is experienced by parts of it. The many worlds interpretation does not tell you which world you are in. It tells you that there is no single world to be in. Reality is not one thing happening once. It is everything happening, all the time, without a mechanism that chooses between them. Whether this picture is correct remains unsettled, but it exposes a possibility that cannot be easily dismissed, that the universe does not simplify itself for your benefit, that it does not collapse into a single story, that what you call reality may be only one thread in a structure that never resolves into one outcome, and once existence multiplies without resolution, the idea that the universe must make sense as a single narrative begins to quietly dissolve. The price of mathematical consistency. These interpretations are not chosen for comfort. They are chosen because the equations work. Attempts to restore intuitive realism often introduce contradictions. The universe resists being forced into familiar categories. Mathematical coherence demands conceptual sacrifice. You might hope that the strangeness encountered so far is optional, that with enough ingenuity, physics could recover a picture of reality that resembles common sense. Objects with definite properties, a single history, causes producing effects in an orderly sequence, measurement revealing what was already there. This hope has guided many attempts to reinterpret quantum mechanics in more intuitive terms. And again, those attempts run into walls. Whenever an interpretation tries to preserve too much of classical realism, something else breaks. If you insist that particles always have definite properties, you must accept non-local influences that conflict with relativity. If you insist on locality, you must give up the idea that properties exist prior to measurement. If you insist on a single history, you must add collapse mechanisms that do not fit cleanly into the theory's mathematical structure. Each rescue attempt carries a cost. The unsettling interpretations persist not because physicists enjoy them, but because they minimize contradiction. They take the equations seriously and refuse to add assumptions that are not required by the formalism. The universe is not being described to satisfy intuition. It is being described to remain internally consistent. This reveals something important about how knowledge advances. Intuition is not a reliable guide at fundamental scales. It evolved to handle medium-sized objects moving slowly through space. When pushed beyond that domain, it becomes a liability. The mathematics, by contrast, continues to work even when it leads to conclusions you do not like. Mathematical consistency acts as a filter. It allows only certain conceptual frameworks to survive. Ideas that feel natural but generate contradictions are discarded. Ideas that feel alien but remain coherent are retained. Truth is not selected for familiarity. It is selected for stability. This process strips away assumptions you did not realize you were making. That reality must be local. That time must flow. That objects must exist independently. That probabilities must reflect ignorance rather than structure. None of these are required by the equations. All of them are optional, and most of them turn out to be incompatible with at least one well-tested part of the theory. What remains is a picture of reality that is lean but demanding. It does not promise a story you can visualize. It promises predictions that hold. It asks you to trade understanding in the intuitive sense for understanding in the structural sense. This trade feels costly because it removes the sense that the universe is built to be comprehensible to you. The mathematics does not bend to human categories. It exposes their limits. It suggests that the universe does not care whether its deepest structure can be comfortably imagined. This does not mean that interpretation is arbitrary. The constraints are severe. Any acceptable interpretation must recover classical behavior at large scales. It must respect experimental results. It must not contradict itself. The space of possibilities is narrow. The fact that the remaining options are unsettling is not an accident. It is a consequence. You are witnessing the price of insisting that reality makes sense on its own terms. This price is not paid all at once. It accumulates. First, you give up solidity, then locality, then a single timeline, then a flowing present. At each step, you could stop and declare the result unacceptable. But the equations do not stop with you. They continue to point in the same direction. Mathematical coherence becomes the final authority. It does not tell you what reality feels like. It tells you what reality cannot be without contradiction. Everything else is negotiable. This places you in an uncomfortable position. You must decide whether to trust the tools that have consistently predicted the world, even when they undermine your intuitions about it. So far, physics has chosen to trust the tools. The result is not a complete picture. It is a constrained one, a framework that works precisely because it refuses to add unnecessary assumptions. What is lost is not truth, but comfort. And as the demand for consistency deepens, the universe increasingly appears unwilling to be reduced to the categories you started with, not because it is mysterious by design, but because those categories were never fundamental to begin with. Simulation as a consequence, not a fantasy. If reality is informational and relational, the idea of simulation stops being science fiction. It becomes a natural extension, not because someone is necessarily running it, but because the universe already behaves like a computed structure, constrained by rules rather than substance. You are used to associating simulations with intention, a programmer, a machine, a purpose. Virtual worlds feel artificial because you know they were built. When the idea of a simulated universe appears, it is often dismissed on those grounds alone. It seems to require an external agent, a designer, a motive. But the unsettling shift comes when you remove those assumptions. If the universe is fundamentally described by information, constraints, and transformations, then it already resembles what you call a computation, not metaphorically, but structurally. States evolve according to precise rules. Certain transitions are allowed, others are forbidden. Information is conserved. Complexity emerges from simple operations applied repeatedly. Nothing in this description requires intention. A simulation, at its core, is not defined by who runs it. It is defined by how states are updated. From that perspective, the universe does not need to be implemented on a machine to behave like one. It only needs to obey consistent update rules. And that is exactly what physical law provides. This reframes the question entirely. The issue is no longer whether reality is a simulation in the familiar sense. The issue is whether the distinction between simulated and non-simulated remains meaningful once substance is removed from the foundation. If there is no underlying material that reality must be made of, then asking what it is implemented on may be the wrong question. There may be no deeper hardware. There may only be rules that define which configurations are possible and how they relate. In this context, physical constants resemble parameters. Laws resemble algorithms. States resemble data. Space and time resemble indexing systems that organize transitions. None of this implies that the universe is fake. It implies that it is formal. This is why the simulation idea persists among serious thinkers, despite its speculative tone. It is not because evidence points to artificiality. It is because the structure of physical theory increasingly resembles the structure of abstract systems that do not require material grounding. You already accept this kind of grounding elsewhere. Numbers exist without being made of anything. Logical systems exist without occupying space. Mathematical objects have properties and relationships without substance. Physics may be revealing that reality itself belongs to this category. From this angle, simulation is not a claim about deception. It is a claim about ontology. It suggests that existence may not require material instantiation at all. What exists is what is consistent within a set of rules. This also dissolves the need for a simulator. If the universe is self-consistent, nothing external is required to run it. It does not need to be executed step by something else. Its structure may be timeless, like a mathematical object, with change emerging internally rather than being driven from outside. The discomfort arises because this strips away the last intuitive anchor. If reality is not made of substance, not located in space fundamentally, not unfolding in time at the deepest level, and not grounded in a material substrate, then it begins to resemble something closer to a specification than to a thing. You might object that computation requires time, but earlier assumptions about time have already been weakened. If time is emergent or perspectival, then computation need not unfold globally. It can be defined relationally, as constraints between states, rather than as a process ticking forward. This removes the dramatic framing of simulation narratives. There is no hidden room, no switch to turn off, no privileged outside perspective. The universe does not run on someone else's computer. It simply is what its rules allow. The unsettling conclusion is not that you are living in an illusion. It is that the distinction between illusion and reality depends on substance, and substance may not be fundamental. If reality is a structure of information obeying constraints, then calling it simulated adds nothing. It merely reflects discomfort with a universe that does not ground itself in the way you expect. Simulation, in this sense, is not an alternative hypothesis. It is a consequence of taking modern physics seriously. And once that consequence is acknowledged, the question shifts from who built the universe to whether the universe needs to be built at all. Laws without a lawgiver. The laws of physics describe regularities, not commands. They do not explain why these laws exist instead of others. Some theories suggest all consistent laws exist, with reality selecting one by internal necessity. Existence becomes a statistical outcome among possibilities. You are inclined to treat physical laws as rules that govern the universe. They feel prescriptive, as if reality must obey them. This language is convenient, but it is misleading. Laws do not compel matter to behave. They summarize patterns that persist. They are descriptions of what happens, not explanations for why it must happen that way. When you ask why these laws exist, physics offers no answer. It tells you how reliably they work, not where they come from. The equations remain silent on why their particular form is realized rather than some other equally consistent alternative. This silence becomes more noticeable as theories grow more abstract. At fundamental levels, laws appear less like instructions and more like constraints. They define which relationships are allowed and which are forbidden. They do not push the universe forward. They carve out a space of possibilities within which reality can exist without contradiction. Some approaches take this to its logical conclusion. They propose that there is no unique set of laws at all. Every mathematically consistent set of laws exists in some sense. What you call the universe is one realization among many, not chosen by design, but selected by internal coherence. In this view, Reality does not ask which laws it should follow. All laws that can exist do exist. What distinguishes your universe is not preference, but compatibility. Only certain combinations of laws allow stable structures, complexity, and observers capable of noticing them. Existence becomes conditional. Not everything that is possible becomes experienced. Only what is internally consistent and self-supporting persists long enough to be observed. The universe you inhabit is not privileged. It is survivable. This reframing dissolves the need for a lawgiver. Laws are not imposed. They are discovered because only certain regularities can sustain a world that includes you. The apparent fine-tuning of constants becomes less mysterious when you consider that most combinations lead to nothing that can ask questions. This does not make the universe intentional. It makes it selective. The selection is not conscious. It is structural. Inconsistent laws collapse into nothing. Consistent ones endure. From your perspective, this feels unsatisfying. You want a reason. You want an explanation that terminates. But this demand may itself be misplaced. Explanations in physics often end with consistency, not purpose. The question why these laws may have no deeper answer than because these laws can exist together without contradiction. This idea is unsettling because it removes the final anchor of necessity. The universe does not exist because it must. It exists because it can. And among all the ways it could exist, you find yourself in one that allows structure, memory, and thought. Probability enters at a deeper level here. Not the probability of events within the universe, but the probability of the universe itself. Existence becomes a statistical outcome among many possibilities. You are not witnessing the only way reality could be. You are witnessing one that persists. This reframes meaning in an uncomfortable way. If laws are not ordained, then meaning is not embedded in them. Order exists without intention. Regularity exists without purpose. The universe works not because it was designed to, but because incoherent alternatives do not. You may be tempted to see this as diminishing reality. In fact, it does the opposite. It removes anthropocentric assumptions. It stops treating the universe as a response to your need for explanation. It allows reality to be what it is, without justifying itself. The laws you observe are not promises. They are not guarantees. They are the current expression of a structure that happens to hold. They could have been otherwise, and in other realizations, they are. This does not make science futile. It makes it precise. Science describes what persists, not why persistence is necessary. It maps the regularities you inhabit, not the total space of what could exist. Once laws lose their role as ultimate authorities, the universe becomes quieter. It stops issuing commands. It simply remains consistent, and your existence within it becomes not a fulfillment of a plan, but a consequence of compatibility. Existence in this sense is not justified. It is permitted. Fine-tuning and fragile existence. Small changes in physical constants would eliminate stars, chemistry, or stability. This fine-tuning invites explanation. Some models invoke vast ensembles of universes. Others accept the coincidence. In either case, your reality looks less inevitable than you assumed. You live in a universe balanced on narrow margins. The strengths of forces, the masses of particles, the rate of cosmic expansion, each sits within a small range that allows complex structures to exist. Alter them slightly, and the world you know disappears. Stars fail to ignite. Atoms cannot bind. Matter never organizes beyond diffuse clouds. This fragility is not a poetic exaggeration. It is a mathematical result. When physicists vary these constants in their equations, most outcomes are sterile. Universes expand too quickly for structure to form, or collapse too fast to allow complexity. Chemistry becomes impossible. Long-lived energy sources vanish. The conditions required for anything resembling life appear only in narrow regions of parameter space. You might initially interpret this as evidence of purpose. The universe seems calibrated, but calibration implies an agent, and physics offers none. The equations do not explain why the constants take their values. They merely show what would happen if they were different. This leaves you with an uncomfortable question. Why this universe, rather than the countless others that seem equally possible, mathematically, but lifeless in outcome? One response is to invoke chance at a cosmic scale. Perhaps there are many universes, each with different constants. Most are empty. A few permit structure. You find yourself in one of those because there is nowhere else you could be. Observation becomes a filter. Existence selects for itself. This explanation does not make the universe special. It makes it typical among the subset that allows observers. Fine-tuning ceases to be a mystery and becomes a selection effect. You do not marvel that the ground supports you because you could not stand where it does not. Another response is to accept the coincidence without explanation. The constants are what they are. They could have been otherwise. There is no deeper reason. This position is logically consistent, but it offers no comfort. It leaves the fragility exposed without justification. In both cases, inevitability disappears. Your universe no longer appears as the natural or necessary outcome of physical law. It appears as one viable configuration among many that never manifest as experience. Whether you attribute this to multiplicity or to brute fact, the conclusion is the same. Reality did not have to be this way. This realization subtly shifts your relationship to existence. You are not living in a universe that was destined to produce you. You are living in a universe that happens to permit you. The difference is quiet but profound. Fine-tuning also undermines the idea that the laws you observe are uniquely determined. If small variations erase structure, then the laws themselves do not guarantee richness. They merely allow it under specific conditions. Stability is not built into the framework. It is contingent. This contingency extends downward. Your chemistry depends on atomic structure. Atomic structure depends on force strengths. Those strengths depend on constants with no deeper explanation. At every level, existence relies on balances that did not have to hold. This does not make reality fragile in practice. The universe is stable enough for you to exist within it, but it makes it fragile in principle. Remove any one of several assumptions, and the entire structure collapses. The unsettling implication is not that the universe is about to fail. It is that it never had to succeed. The fact that it does is not guaranteed by logic or necessity. It is an outcome that could easily have not occurred. When you combine this with earlier ideas, that laws are descriptive, that space and time are emergent, that history may not be fundamental, the picture becomes harder to anchor. Reality stops looking like a robust, inevitable structure and starts looking like a narrow corridor through a vast space of non-realized possibilities. You stand inside that corridor, not because it was meant for you, but because only within it can standing occur. Fine-tuning does not tell you why the universe exists. It tells you how easily it could have not. And once you recognize that, the sense that reality is a given, something solid beneath your feet, begins to erode. Existence in this light is not the default. It is the exception that happens to include you. consciousness as a late arrival. You might expect consciousness to anchor reality. Physics offers no such role. Consciousness appears as a process within the system, not a foundation beneath it. Awareness does not stabilize existence. It observes patterns already constrained by deeper rules. It feels natural to place consciousness at the center of things. Your entire access to the universe is mediated by experience. Every fact you know is known because it appears to you in awareness. This makes it tempting to assume that consciousness must play a fundamental role in bringing reality into being. Physics does not support this assumption. In every successful physical theory, consciousness appears late. It is not part of the basic equations. It does not enter into the description of particles, fields, space-time, or information. The universe evolves, interacts, and organizes itself long before anything capable of experience arises. Stars form, galaxies collide, chemistry unfolds, all without awareness. When consciousness finally appears, it does so as a complex process embedded in physical systems. Brains organize matter in specific ways. Neural activity correlates with experience. Damage the structure, and experience changes. Alter the process, and awareness fades. Nothing about this suggests a foundational role. This is unsettling because it removes a familiar anchor. If consciousness is not fundamental, then reality does not depend on being perceived. The universe does not wait to be observed in order to exist in some definite way. It does not require awareness to settle into facts. Earlier ideas might have suggested otherwise. The role of observation in quantum mechanics can sound like a privileged place for the observer. But as you have already seen, observation does not require consciousness. A detector suffices. An irreversible interaction suffices. Awareness adds nothing to the mechanism. This distinction matters. Consciousness does not collapse wave functions. It does not select outcomes. It does not fix reality in place. It merely registers results that have already been enforced by physical interactions. This places consciousness in a humbling position. You are not the ground of being. You are not the reason the universe becomes definite. You are a pattern that emerges within a reality that was already constrained long before you noticed it. Some have tried to resist this conclusion by proposing that consciousness itself is fundamental, perhaps even responsible for physical law. But these proposals have not produced testable theories that outperform existing physics. They remain speculative overlays, not explanatory frameworks. What physics does suggest is that consciousness depends on specific informational and energetic conditions. It arises when systems reach a certain level of complexity, integration, and stability. It is contingent. Remove the conditions, and it disappears. This contingency is important. It means consciousness is not inevitable. Most of the universe is not conscious. Vast stretches of space and time unfold without experience. Awareness is not the default state of reality. It is a rare and local phenomenon. This does not make consciousness insignificant. It makes it fragile. Your awareness feels continuous and central because you cannot step outside it. But from the universe's perspective, it is one more emergent process among many, no more fundamental than temperature, pressure, or life itself, important locally, irrelevant globally. This reframing alters how you think about meaning. If consciousness does not anchor reality, then meaning is not written into the universe. It is constructed within conscious systems. Value does not descend from physical law. It arises from perspective. This can feel destabilizing. It removes the idea that the universe is somehow about you, or even about awareness in general. Reality does not organize itself to be known. It simply is, and sometimes produces systems capable of knowing. You observe patterns that were already constrained by deeper rules. You do not impose those rules. You do not finalize them. You inherit them. This also explains why consciousness cannot resolve the deeper paradoxes you have encountered. Awareness does not explain why laws exist, why constants take their values, or why reality is structured at all. Consciousness is downstream of those questions, not upstream. The unsettling implication is that even your most intimate certainty, your own awareness, does not grant you access to the foundation of existence. It does not stabilize reality. It floats atop it, dependent on conditions it did not create. Consciousness arrives late, observes briefly, and leaves no mark on the underlying structure it witnesses. And once you accept that, the universe becomes quieter. It no longer needs to be seen to exist. It no longer waits for recognition. It unfolds according to constraints that do not care whether they are noticed at all. The observer problem, revisited. If observation does not require consciousness, then your role is reduced. You are not collapsing reality into place. You are registering outcomes selected by interactions beyond you. The universe does not wait for you to look. This conclusion quietly dismantles one of the last places where you might have hoped to matter at a fundamental level. If awareness is not required for measurement, then the observer is not a privileged participant in the structure of reality. You are not standing at the center, calling facts into existence. You are encountering facts that have already been enforced by processes that do not involve you. The observer problem, in this light, changes its meaning. It is no longer a question of how consciousness influences physics. It is a question of why the language of observation felt misleading in the first place. Early formulations of quantum mechanics borrowed everyday terms to describe unfamiliar processes. Observation sounded like looking. Measurement sounded like checking. But the physics never depended on those connotations. What matters is irreversibility. When a quantum system interacts with its environment in a way that spreads information beyond recovery, alternatives are suppressed. A result becomes fixed relative to that environment. This happens constantly. Photons scatter, molecules collide. Thermal noise disperses correlations. The universe is performing measurements everywhere, all the time, without awareness. You arrive after the fact. By the time you observe something, the outcome has already been selected by interactions that left a trail in the environment. Your act of looking does not finalize reality. It adds another layer of correlation to an outcome that was already constrained. This reframing strips away a subtle form of anthropocentrism. You are not the reason the world appears definite. You appear within a world that is already behaving as if it were definite at your scale. Your certainty about outcomes reflects the effectiveness of decoherence, not your involvement in it. This also explains why the world feels classical to you. You never encounter superpositions of everyday objects because the conditions that would allow you to do so are erased long before awareness could register them. The environment enforces definiteness with overwhelming efficiency. You experience a stable world because instability does not survive to your level. The observer problem, then, is not about why you see a definite outcome. It is about why definiteness emerges at all, and the answer does not involve you. This can feel diminishing. It removes the last trace of special status you might have claimed. You are not required to complete the universe. You are not consulted. You are not central to the mechanism. But this also resolves a tension. If consciousness were required to stabilize reality, the universe would be inexplicably dependent on rare and late-arriving processes. Vast stretches of cosmic history would be undefined until something capable of experience appeared. Physics does not support such a picture. Instead, reality stabilizes itself through interaction. Awareness is optional. You still matter locally. Your measurements matter to you. Your records matter within your branch of experience, but they do not matter to the universe in the sense of determining its structure. They are consequences, not causes. This realization aligns with a broader pattern. Each time intuition suggests a central role for something familiar, solidity, space, time, consciousness, deeper analysis reveals that role to be derivative. What feels primary turns out to be contingent. What feels obvious turns out to be late. The universe does not organize itself around your perspective. Your perspective is organized by the universe. Once this is accepted, the observer problem stops being a mystery about perception and becomes a lesson about humility. The world does not depend on being seen. It depends on consistency, constraint, and interaction. You are not collapsing reality into place. You are reading a result written by processes that do not know you exist, and the fact that those processes reliably produce a world you can inhabit is not a testament to your importance, but to the stability of the rules that preceded you. The universe does not wait for you to look. It never had to. Meaning, without fundamentality. If reality is emergent, probabilistic, or relational, then meaning is not built into the universe. It is constructed locally. This does not make it false, it makes it contingent. Value exists without being written into the equations. You may have expected meaning to be anchored somewhere deep, in the structure of the universe, in the laws that govern it, in a purpose embedded at the foundation. This expectation is understandable. If reality itself has a reason, then meaning feels secure. Physics offers no such anchor. The equations describe how systems evolve, not why they should matter. They track probabilities, constraints, and transformations. They do not assign significance. Nothing in them privileges one outcome over another as meaningful. They remain indifferent. This indifference can feel like a threat. If meaning is not fundamental, does it dissolve into illusion? Does value become arbitrary? The answer depends on what you require meaning to be. Meaning does not need to be universal to be real. It needs to be operative. It needs to shape behavior, experience, and choice. Local construction does not imply falsity. Temperature is not fundamental either. It emerges from molecular motion. It is still real. It still matters. Meaning arises in systems that care. Consciousness introduces perspective. Perspective introduces preference. Preference introduces value. None of this requires that value be written into the fabric of the universe. It requires only that systems exist, which differentiate outcomes. From this view, meaning is relational. It exists between a system and the conditions it inhabits. A goal matters to you because of how you are structured, not because the universe endorses it. This does not weaken the goal. It explains it. The discomfort comes from the loss of absolutes. If meaning is contingent, then it could have been otherwise. In different conditions, different values would emerge. There is no single narrative the universe insists upon, but this contingency is not nihilism. It is constraint. Meaning is not arbitrary because not all meanings are sustainable. Some values lead to coherence, others lead to collapse. Systems that persist develop meanings that allow persistence. Value evolves. This mirrors earlier themes. Laws persist because they are consistent. Structures persist because they are stable. Meanings persist because they support the systems that hold them. Nothing here is imposed from outside. Everything emerges from internal necessity.